Hello everyone and welcome to this video. It's now been about 8 months since I introduced the category Advanced FDM to the monthly releases that we make with Arbiter Miniatures. And ever since the first release, I've been continuously trying to improve the process of making the advanced FDM miniatures and improving the experience you get when you print them and do the whole support removal and cleanup process. And this past 2 or 3 months, I've made some very significant progress on that whole thing. And this latest release that I'm releasing today with the Death Knights Part 2, the Hell Horse Riders, with these mounted Hell Knights, I've been able to really solidify my whole process, and I think now is a good time to do a walkthrough video and show you exactly what it's all about, both for those of you who are not yet familiar with the advanced FDM models, and maybe it will also be able to help those of you who've already supported that tier and tried some of the models. So yeah, this will be a walkthrough of the entire post-processing process of one of the mounted knights, and also I'll be sharing my thoughts about why I'm creating these types of models and how. So to get started, let's start with the why. Why am I making the advanced FDM models? And to illustrate that, I'll bring up this pit fighter, this human pit fighter from the September release, 2025. And this is the kind of model I've been doing ever since I started creating miniatures. Back then, I did not have a proper location for a resin printer to handle the toxic fumes and stuff like that, since I was living in a small apartment. And that's why I got into trying to get high quality miniatures on FDM machines in the first place. And I'm inspired by a lot of other people in the scene, like Daniel Herrero and Tom Tullis and those kinds of people. I really got deep into supportless miniatures and trying to push quality and drama in the supportless miniatures as much as possible. Something which I'm still chasing today, with every release, trying to get as much life and drama into the supportless models as possible. And the supportless models are very handy in the way that they're really a no-brainer kind of print, because no matter whether you use an FDM printer or a resin printer, it's just you just throw them on the print plate and no supports, I mean, they're really what do you say? Easy to work with. You get very, very rare print fails with them, because if you have a print fail on the supportless miniature, most likely it's a machine problem and not a model problem, because it's just such a simple print and the print head doesn't move around as much and all those kinds of things. So they're very, very convenient and easy to handle, and you get a great result every time. So they're great, and I still want to get as much out of them as I can. That said, I still started wanting to do more, and then I did a resin-only projects once, the one called Hellgate that I ran on Kickstarter. And yet that just gave me such a joy, being completely free to pose and design the characters exactly how I wanted them. And yeah, but I didn't really like that I had to sacrifice the FDM part, and to be honest, I didn't really enjoy the resin printing process at all. I finally got a separate place for resin printing, and I do have a resin printer, and I can print those kinds of models, but the whole process is just very messy and time consuming and space consuming. I know there are very different opinions on resin printing online, but I do take it very seriously, and I do take the fumes and the chemicals and the toxic aspect of it very seriously. I think I work from better safe than sorry kind of philosophy with that, and therefore I really wanted to try and see if I could do resin-like models on the FDM machine. And when I say resin-like, I don't mean that I'm hallucinating and thinking that the surface quality and definition equals that of a resin print. It absolutely does not. But what I mean is, if I could use FDM and get the freedom to pose the characters and design the characters the way I want without being sort of ramshackled into having to make everything have a specific angle and support itself. So for the longest time, I printed using a standard printhead at 0.4 millimeter. I mean, the nozzle. And I didn't really try out the smaller ones. But once I did try a 0.2 millimeter nozzle on the supportless models, the jump in quality was so significant that it gave me a renewed interest in trying to do resin-like models with the FDM, because the models were so crisp and so well defined that it just really poked my interest, and that really was the beginning of the advanced FDM models, as I got into using the 0.2 millimeter nozzle and found that it wasn't the kind of hassle it seemed to be in the early days of FDM printing. It just worked really well. If you get a really high quality filament, and you have the new printers, like I use the Bambolab A1 and A1 minis, and the A1 minis are printing absolutely insane FDM detail right up out of the box, and I have a couple of them, and it's been the same thing. No tweaking, no nothing. The only thing I'm doing is I use the print profile from Tom Tullis of Fat Dragon Games, but I ran tests on the standard profiles as well, and it works just as well. Here is what the same model looks like in the advanced FDM version. And one thing is the posing, but also, the whole design aspect of the model becomes so much more interesting, because really the process is exactly how I would design a resin model as well, because I still have certain tolerances I don't want to go below, just to make sure that the models are paintable. I have very set tolerances for what a detail size can be to make it fun to paint and not a hassle, but also to make sure that model strength and sturdiness is in a level where it can be handled and played with on the table without having like an excessive risk of model breaks and so on. So seeing results like this possible on FDM really got me fired up, and also made me want to try and see, okay, so we can get a really clean looking and well detailed model in raw print, but what would that model look like once it's primed and painted? Because sometimes raw print photos can be a little bit forgiving, since the plastics have varying degrees of subsurface scattering properties to them, so you don't see the small defects quite as clearly as you do once you prime and paint the models. And that led me to doing a couple of paint tests, like one of those you can see here. It's one of the Death Knights from one of our previous releases this year. So this is an advanced FDM model, so it's printed in FDM plastic, and it's printed using a 0.2 millimeter nozzle on a Bambolab A1 Mini printer, and then painted up using regular acrylics from Army Painter Fanatic line. So I just I wanted to do something like this because normally I paint on the resin versions of my prints, but I really wanted to do like a real world test and see, like, can you actually get something, is there enough quality in these prints to allow you to do more careful painting, like painting that you spent a little bit more time on? Can you do proper layering? Can you do edge lining? Can you do recess shading? And it turns out you can. So I'm not a display level painter or anything like that, but really, yeah, just try and take this example for what it is. So you can do glazes, you can do proper transitions in non-metallic metal and stuff like that, and proper material indication. You can, while the surface detail, like I said, is not resin level, it's close enough where you can paint individual models and striations and details in the serratas, and a lot of the surface detail is there, and even the fingers come out clean, so you can paint and shade the knuckles and stuff like that. So it's really an exercise in was it possible to get the advanced FDM models to a point where it could be a good looking model on the table? And I think in that regard, it's a solid success, and it's something that I'm really excited about. So that ended up being a very, very long ramble as usual. So yeah, but that's kind of the background and the why and how of these models. And now I want to take you through the process of the most recent advanced FDM model, one of the Death Knights on Hellhorse models that just released on October 1st, because it's by far the most intricate print I've done in advanced FDM so far. And it also marked a point where I really have the process of designing the models and supporting them nailed down. So it's a very, very easy to explain process, and it's been, like I said, almost 8 months now, and I'm at a place where I feel like the process is so refined now that this is how it's going to be moving forward. Of course, I'll still try to improve and tweak my process as I go along. I always do that, but yeah, I think I just felt like it's in such a solid place now that it's time to do a video and really try to explain and show the benefits of this type of model. So here is the main part of the rider model, which is the horse body and the lower body of the rider himself, and this is straight off the printer. So I used three tools for the cleanup process. One is a standard clipper that comes with pretty much every 3D printer. Just a basic one, nothing fancy here. And then I use a hobby knife and a small blowtorch style lighter. The supports you see on these models are, while they are in the style of resin printing supports, they are quite different since we are not dealing with the same challenges as you do on a resin print, where you are mainly dealing with gravity and suction forces. On these advanced FDM models, the support function is quite different. So you will see the structures are beefier than you would normally see on a resin print, and they are grouped in sort of clusters that serve to generate more stability, as one of the main issues printing advanced FDM models is stability, especially as we go further and further up and away from the print plate. So the reason why the most important reason why these models work as well as they do is that every single part of the miniature is sculpted in directly in the angle that they're going to be printed on, and also the points where you see these supports connect to the model are pre-planned already at the very early sculpting stage. So everything here is custom made, if you will, or it's made intentionally to be possible to print this way. Of course, you could apply these sorts of supports to any kind of resin model, but you would be dealing with a lot of issues with severe overhangs and poor surface quality and a million of supports that would eventually be, incredibly hard to remove and also result in a subpar quality. So the clustering or the grouping of these supports serve as a means to get the stability that you need, and then once they converge into the point that connects to the model, they are then aligned in a way where they sort of pull away in one dimension, or otherwise leave as much as possible a very convenient, how should I explain this? Like a convenient amount of space around it for you to be able to access it with your clipper. And generally, when you get to remove these supports, you sort of work your way around the model and remove one tower at a time. Here you can see one of the towers highlighted. So these are the kind of groups you're looking for. Then you will sever it from the connection point with the model and then pull away the tower one by one. In taller, larger prints like this one, you will sometimes find small inter-tower bracings that are much thinner than normal, and these will not print super clean necessarily, but they will print enough to add some more stability to the print. So when you get to the support removal part of this process, you will want to sever these small inter-tower bracings first, because they're only there to provide stability to the print during the printing itself, but they will make it harder to remove the tower. So go in and sever these small inter-tower bracings first, and that will make it much easier to pull each tower away. With all that said, now it's time to get into the practical demonstration, where I will remove all the supports from the parts for this model and do an assembly afterwards. So, like I've already explained, this will be me just starting to work my way around the model, as you can see, first thing I do is try to get as clean a cut with the clipper at the point where the support tower meets the model. And then after severing that point with the clipper, I pull one of the main pillars of that particular tower and just pulls it away from the print base. And as I do this, I make sure to sever the small inter-tower bracings whenever I find them before clipping away the tower and removing it. And yeah, this is just a process of working your way around the model piece by piece. And if there is a support connection point that you can't really access, then just rotate the model and start working from another angle. All these towers are hand placed in a way that you will be able to sort of work your way from the outside in, like scratching off layers like on an onion. So yeah, don't worry if one of the points is currently inaccessible. Just move on to another part of the model, and eventually even the innermost points will be accessible with your clipper. As you work your way around the model, it's always a good practice to sever the outmost points first, the most vulnerable points. So let's say you want to remove the supports around a strand of hair, then or a tip of a sword or any other like thin, fragile part, then always remove the supports at the very tip of that part first, and then work your way inwards, because closer to the main body of the model, there will be more structure and tension and stability, and so you're not as likely to break anything that way. And also, when you're severing very thin parts, then it's a good practice to use only the very tip of your clipper very carefully to sever the connection point. If you use the part of the clipper that's further in between the two clipping blades, the simple fact that the blades themselves are pretty thick and the cutting angle of the clipper blades are quite steep, that will function as a wedge and sort of push against the plastic, and that will increase the risk of breaking very thin, delicate parts. So when you're handling the more delicate parts of the model, always use the very tip of the clipper to avoid any unwanted breaking of parts. For the sake of saving time, I'll speed up the rest of the support removal process and return to normal speed once we get to the surface cleanup. With all the supports successfully removed, it's now time to take the hobby knife and carefully trim away any leftover small bits of support contact points, and also any area where during the print process along some edges, as the printhead moves away, it will sort of curl up a small line of plastic, and you'll just remove those carefully, bit by bit, just like you would remove any mold lines on a plastic sprue miniature kit. Once an area has been cleaned up with the hobby knife, I go in with the torch style lighter and just quickly do some quick bursts of heat, and that will close up the surface. And if you have big areas, you can quickly stroke a finger across the heated surface after a small burst, and that will clean up any last imperfections. And that is the process really. The rest of this will just be rinse repeat of carefully severing the contact points using the clipper, then going over the area and cleaning up the contact points and curl lines with the hobby knife, and then finally using very small bursts of heat with the lighter to close up the surface. And so I'll just speed up the video once again until we get to the final assembly point. And here are the final cleaned parts of the model all ready to be assembled. To glue them together, I just used a standard Loctite super glue. I do have other types of glue also with activators, but the actuators will sometimes leave white blemishes on the raw plastic. So for this demonstration, I'll just use very simple regular super glue. I generally find that it works best if you don't put on too much glue, just enough to fit into one of the assembly holes, and then just give the parts a good squeeze together. And if you don't touch them too much, that will stick just fine, and even hold up the weight of the different parts as the glue sets. And this is how the final model looks, all cleaned up and assembled, but still in its raw plastic stage. So this is before priming. I hope you enjoyed this video and didn't find it too long and rambly, and I hope that it gave you a good understanding of what the goal is with the advanced FDM models, and what the process of dealing with them is like, and what sort of results you can expect. Thank you all for your time, and hope to see you on the Discord.